Hello, my name is Asar Naeem and my student ID number is 2172437761. So now I'm going to start my presentation, building a system prototype. So these are the requirements to build a system prototype. This is the cycle that you have to follow, where first you put initial requirements, then you design, prototyping, customer evaluation, review, and updatation. You have to repeat this cycle until the customer is satisfied. And when the customer is satisfied, you have to do the development phase, test phase, and maintain phase. A prototype is a model which is used, sorry. A prototype is a model which is used to demonstrate that how a team will develop a system using specific prototype. So there are some points to note. Identification of basic requirements, which includes the input and output information desired, development of initial prototype, review by the customers and end users, and the necessary feedback obtained, revision and enhancement of the product using the feedback received. These are the points you have to note. Okay, so next. Okay, so now let's come to the building a system prototype. System prototype should be designed before starting any project or system. Building a system prototype will help to complete a project on time. A system prototype helps to detect errors in early phase, identify missing functions not done. Okay, let's come to the prototype types. So there are 4 different types of prototypes, and there are a bit more, but I'm going to explain them afterwards. So types of prototypes: throwaway prototyping, evolutionary prototype, incremental prototype, extreme prototypes. These types are applied according to the system requirement. Okay. So there are different models of prototype to look like waterfall, modified waterfall, rapid development. These models are used for SDLC, software development lifecycle. So these are the different models that are used in SDLC as well, excluding these ones. Okay, so problem domain. Embedded system contains hardware and software to develop an embedded device. The problem domain is a small. Automobile and electronic industry doesn't design system prototyping before development of their embedded device. They will complete their development, but the reviews of users will be worst of their device. So problem, let's come to the problem. Remote stand fans. These fans, like these, mostly the remote stand fans that are made in China, these fans are example of real time, which will work very good for 30 to 60 days. After that, remote won't work and the sensors from circuits are spoiled. There's another example like China cars. There are some cars which looks like best car, but which looks like the best car in the market, but in few months, the computer component like the motherboard or the you can say the sensor card of the car will show errors without any reason, and the sensor will stop working, like brake sensors, distance sensors, or ABS, automatic brake system. So there are some points to note here. A lot of other industries also doesn't follow prototypes and software methodology, which occurs error when the product are in market. While using prototype at the stage of test, your product will be tested, and if the customer is satisfied, then only it is marked as done. Otherwise, the cycle of prototype repeats and fix bugs and errors, like the cycle I just showed you in the first slide. Okay, so let's go. So these are the images. As you can see, the China stand fan that I was talking about and the car, the Chinese car, United Bravo. Okay, now industry solution. As the automotive industry have decided to design a system prototype in which they will test the car computer many times and they will fix the bugs and errors to maintain performance. And now come to the remote control fan. This Chinese remote fan needs a better PCB and sensors for that company. For that company have designed extreme prototype and waterfall model for the software side where they will process this design implement, development, test, and maintain. Industries, after fail of their products, have decided to follow a best prototype model and test their product until customer or user are satisfied. Okay, let's go to challenges. Challenges: design prototype to follow instruction to develop project, design diagrams to get anticipated outputs, design hardware with better quality, implement on printing circuit board, development software to connect hardware, get user feedback, test of device, maintain errors occurred while testing, fix and test again. So these are the challenges. Opportunities for embedded system. Modern embedded systems, electronics, like modern embedded electronics, be it for the consumer, commercial, or industrial applications, have become increasingly complex. Microchip has developed an ecosystem of development hardware and software, not only easing the burdens of early design, but also enable a seamless transition to the production of embedded electronics. To avail these opportunities, we have to use system prototypes to reduce complex from project and to give a good output of embedded device. Sorry. Okay, so let's come to the purpose solution for myself. According to me, so this is my solution. So according to me, any project which have many end users should design a prototype and follow it. Designing of system prototype, it depends on project time and functions required. Implementation of system prototype. After designing phase implementation, phase will give result of the system implementation of rapid prototyping as. So yeah, let's come to designing. Well, designing is the part is the main part in prototyping, because you should know which prototype will work best for the project. As embedded system consists of hardware and software too, so designing the best model for your embedded system depends on time frame and required output and functions of the project. Most of the average size project use evolutionary prototyping, which is flexible for all projects, in which we can add new features and test it during the requirement and design phase. Implementation. So these are the things that I'm explaining. Implementation. So first I explained designing and now I'm explaining implementation. Rapid prototyping and reconfigurable platforms will significantly diminish the development cycles and reduce costs. Previously, several approaches have been proposed, i.e. prefabricated SoC, embedded configurable logic on FPGA or NIOS. Yet, with the drawbacks of high cost, the mastery of complicated WHDL programming, and unfaithful representation of the hardware, this paper proposes a solution by adding an interconnection module between the minimal system and peripherals. As the central role of the module, FPGA can quickly redefine the pins and connections through programming to show the platform and convenience and rapid prototyping ability. Yeah. So this is my presentation. I hope you like it. Goodbye.